pulsing at the rate of AC peaks of power energy, which would be 120 times a second. The same principle actually as this, except it's done with vacuum tube oscillators rather than a spark gap system. And so it has very few parts, not much to it, but the coil it's about 1,500 turns on about a 3.5 inch diameter cardboard coil. And that took quite a bit of time. And the amazing thing was when you're 14 years old and you build something like this and turn it on and it works, you are amazed yourself because you don't know much about circuitry. You're just following directions. And I wasn't creative enough to come up with the design. So we're going to demonstrate this, and I think before we begin, I just want to be passing around something for the benefit of those that don't. I'd like to have some volunteers, maybe 9 or 10 people come up within maybe a 6 to 10 foot diameter of this. Where's my black notebook? What did I do? Oh, here it is. Meanwhile, for the rest of you, and I'll pass this around. Here's a captured spark in lucite, so you can see how delicate real sparks are if you take them one at a time. I think we'll try to maybe come around.
How many more do you need?
6 or 8. Probably could do
Get a few
8
more.
or 9 maybe.
Okay, need some more up here. Come
Yeah,
on.
and just we'll leave this gap open so
We promise you won't get electrocuted.
Yeah.
I think.
What?
You're wearing jeans with ribbons. We're all screwed.
There's use some of your bulbs too.
Sure, go ahead.
And I want everybody to take one bulb. You don't have to do anything with it. Just stay within something like 6 or 10 feet back from the coil. And here's one that's a little different. Here, somebody could take a circular one. Everybody we need some long ones over here. Would you like one?
They want to, yeah.
It might not work at that distance, but you'll see.
You're classy.
So we've got to let these. This is a neon light gas discharge tube. We brought it along because I need a neon light, and I'll hold the neon light. So after a little bit of time, so that the electrons can start boiling off the plate, you'll have to turn off the fluorescent lights to see this. And now bring your bulbs in just a little bit. Face yourself around.
You guys need to move it a little bit. There you go.
But it won't hurt if you touch it. I've done this. So as you can see, what we have is a lot of energy up here in space. We have a lot of power generated by this system. In fact, when you get it loaded enough, you see the spark is stopped. And it's still sparking a little bit, but basically we're sapping off some of the energy in the space around it. So you can have a lot of fun because something like this you can try a number of different experiments with, and we're only going to have time to do just maybe 3 or 4, and that's all we can do. But there's a lot more that can be done. Notice different fluorescent bulbs have different phosphor, different gases inside, so they have different colors. So these are the natural light variety, and these are the white light variety. And you don't need wires. They can be burned out. In fact, I only use burned out bulbs because I can't afford to waste money on new ones. So that's the light demo here. And you'll notice that a neon bulb is really pretty good too. This is a neon bulb. And I have one other bulb here. Let me see where's my light? Where's my light? Oh, here. And of course, you see a lot of pictures with with a fluorescent bulb that, actually, did you know Edison invented the neon bulb? That was one of his 700 inventions. And this, the neon, is one of the fluorescent lights, one of these economy type lights that, you know, takes 15 watts and produces 60 or 100 watt light.
Did he look a little bit like Mark Twain there?
So you'll see pictures of Tesla with a coil like this, and so
Yeah.
you can take it.
I should mention too that it's Dr. Ferraro's birthday today, and he told me he actually knew Tesla and did some work with him.
All right. Well, one of the little things that I have here is a couple of little whirly gigs. I guess maybe I can just try the 4-prong one.
In the right place at the right time.
This is a 4-prong whirly gig, and it's just a wire with bent ends, and you're going to get it turn off the light. And now you can see the individual sparks there. It's 120 pulses per second, and you wouldn't know that a spark had force. Or I think it's probably the energy, the heat energy given off, but I don't know the exact physics of this. But you can see it's producing quite a little show here with the sparks generated, and you can see them turn them on, off and on, because this is a pulse generator. I mean, you're putting AC in this oscillator, so you're actually pulsing it with alternating current instead of arc gap. That's the early bottles with copper plates on them. And, oh yes, I have to put on a little bit of an extension to bring this thing out where we can get at it. This just comes to a point. And I have to put actually a little round cap on to make longer sparks. But this is a demonstration of wireless. Actually, it's a demonstration of a capacitor. That's what it is. I'll put this right quite close here. And there's a gap here. And you can see daylight through here. No connection. I think I'll probably do it.
We need over.
And,
Move a little.
yeah, we'll do it. I just want to get these in close proximity. Take my trusty pliers, which, by the way, you'll notice I turn it on and off with pliers. And you should not see anything between them, but you should see a spark over here. So you can actually draw a spark off of this side here. Maybe you can see it.
Every once in a while.
If I put that a little closer, you can. It's an experiment. This is not a real powerful one. I think we're probably generating on the order of probably not more than 25 watts at most with this device. Here are my Zanko bottles. If you've ever had Zanko, it's non-alcoholic. And this experiment is to demonstrate what insulators will do or don't do. And so you would normally think insulators would be good for this kind of device, but you find out that they aren't terribly good. This is just to give it some capacity to ground a long wire, and all you need is a little bit of capacity to ground here. Make a gap, a couple of screws. That ought to do it. test a few insulating devices here.
Don't need a light.
This is what you might make a circuit board out of, just a piece of circuit board material, and of course this part. Well, I'll just show that. I think that's a little bit closer. Parts will go right through circuit board material. If you have a little thicker plastic, Lucite or plastic, goes right through plastic. I have a piece of glass, plate glass. Spark will penetrate plate glass, which you would normally think would be an insulator. And then, of course, the final one is, you've all heard about burning a CD. Well, this is a CD. I think what'll happen is I can put a hole through it.
Don't create any fires, here we have a fire extinguisher.
This is known as burning a CD. Yeah, it did pretty well blackened it. Now, what we'll do is a joint.
We'll show the other one. So give us a few minutes. We're going to take this one down, then we're going to put up the bigger ones here. We'll just fire those off, and that'll be pretty much it. My conventional, very similar, but conventional Tesla coil. It turns out the spark gap is in here, so when this is going, you'll actually see the spark going inside there. That's a spark gap, and it's basically the same circuit. This is the primary winding around here, and all these turns are the secondary winding, and the sparks will come off of that. This is going to make some noise, okay? Okay, I guess we're ready, so. How'd that feel? Pretty good. Okay. Okay, we're going to set the next one. Oh man, there's some ozone up there. Okay, let's set the next one up now. Yeah, no, it's twitching. You want to see it one more time?
About 5 or 6 inch parts there.
Okay, now we're gonna set up the one from the physics department. This is actually a commercial unit. It was built in 1930, and so it's an antique, and it's a little bit different style. Instead of just having the sparks go up off the top to the self-capacitance, it's actually going to spark between these two balls. The capacitance will be between those two balls. There you come up after. This is two wires that are very close together like that, and that's a spark gap. So what happens is when this transformer starts the AC waves coming up, okay, when it gets to the peak, it's charging that capacitor's following the voltage as it goes up. And then finally it gets high enough voltage, 5,000 volts, when it gets to the peak. Remember, it's a square root of 2 times that to get to the peak. Oh, you guys should know that, right? And then this thing will arc over, okay? And that shorts out this circuit. And so then this thing oscillates at the frequency of resonance at a very high voltage, and it couples into this secondary coil here. This is completely isolated from all the rest of this, or we'd get killed if we touched this, okay? And there's many, many turns. If you come up and look at this later, you'll see there's hundreds and hundreds of turns of wire. And then the capacitance is formed here with this coil, and that's tuned to the same resonance as the primary circuit. And that's how you develop the huge voltage. Okay, ready on the lights? Okay, the lights, we'll separate them out a little bit. If you separate this, you'll be able to sometimes see how it won't arc continuously. You might get some lightning strokes between them. I might have to get the distance just right. We'll try it here. Okay, right there, we have a little bit too much separation. As you can see all the streamers going out all along the wire. Yeah, let me move it just a little bit closer. Always get nervous. Like lightning. Okay, we got one last thing here. Let's get the probe. Bill is going to be very brave and touch a. Which one you'll see? I guess. Yeah, that's right. You're going to clip on there. Touch that one. Okay. You ready? Okay, thanks a lot.